Hello and welcome to Algebra 2, Lesson 78. In this lesson, we're going to learn about graphing hyperbolas. So up to this point, we've learned how to graph parabolas, how to graph circles, and how to graph ellipses. So the next thing we're going to come across is how to graph the hyperbola. So these are a little bit more challenging to draw, but again, when you're working with these things, especially if you're freehand drawing something, the expectation is you're just giving a general idea of what it looks like. So with hyperbolas, the equation looks similar to the ellipse. The difference is the minus sign. So I want you to recall that when you worked with ellipses, you had a horizontal ellipse that was short and fat, and you had a vertical ellipse that was tall and skinny. When we look at hyperbolas, you're going to have two different scenarios that occur. You'll have a horizontal hyperbola, and you'll have a vertical hyperbola. So with a horizontal hyperbola, you get this equation in your textbook. You'll see x squared over a squared minus y squared over b squared equals 1. Now let's stop for a minute. Let's go back to when we learned about ellipses. The horizontal ellipse had the following equation. It was x squared over a squared plus it was y squared over b squared, and this was equal to 1. The difference between this equation and this equation is the minus sign here. That's how you know that you have a hyperbola versus an ellipse. Once you figure that out, you have to be able to establish, do I have a horizontal hyperbola? Do I have a vertical hyperbola? And this comes from looking at which term is positive and which term is negative. So in other words, I can think about this term right here. I could say this is plus negative y squared over b squared. So if this term is negative, the term that's positive, if that contains the x variable, we're going to have a horizontal hyperbola. Again, think about the x-axis as being the horizontal axis, the y-axis as being the vertical axis. So in this case, you can think about it as, let's go back to the original. This guy right here, the x squared over a squared, is larger or more dominant than this guy right here, the y squared over b squared. You might say, well, how do you know that? This guy minus this guy equals this guy. If this guy minus this guy equals 1, 1 is a positive number. So for that to be true, whatever I started with, the x squared over a squared, had to be larger than y squared over b squared because I've got a positive amount left. Just think about if you're spending money out of your checking account. If the result of paying a bill leaves your checking account with a positive balance, well, the bill was smaller than what you started with. Okay, so it's the same thought process here. So however you want to remember that, if you want to think about the fact that this term is bigger than this term, or you want to say, well, this x squared over a squared is positive and this guy is negative, however you remember it, this guy right here, the positive one, the one that's larger, that's what's going to dictate if we have a horizontal hyperbola or a vertical hyperbola. In the next one, we see a vertical hyperbola. Now y squared over a squared, this is the larger one now. So it's a vertical hyperbola. Y is on the vertical axis. So we have y squared over a squared minus x squared over b squared equals 1. And again, when you think about the vertical ellipse, what was our formula there? It was x squared over b squared plus y squared over a squared equals 1. Now I could change the order of this around and put y squared over a squared first because there's addition here. But I just want you to notice that the difference again is the plus sign here became a minus sign here. That's how you can tell if you have a hyperbola. Now, for today, we're just going to look at graphing a hyperbola that's centered at the origin. The first thing you need to do is locate the intercepts. If you have a horizontal hyperbola, you will have x-intercepts and no y-intercepts. If you have a vertical hyperbola, you will have y-intercepts and no x-intercepts. And when we get to a problem, I'll show you why that's the case. The next thing you're going to do is find this fundamental rectangle. The points for this, I'll show you how to get those. You'll sketch the asymptotes. These are going to be lines that are extended from the fundamental rectangle, or you can actually get the equation for them from the hyperbola. You can graph them that way. Then lastly, we will sketch the graph. So each branch of your hyperbola goes through an intercept and approaches but doesn't touch the asymptotes. So let's take a look at the first example. We have y squared over 9 minus x squared over 9 equals 1. So in this case, this term right here is larger. So it involves the y variable, so I know I have a vertical hyperbola. So I know this guy is vertical. So what I told you is that if you have a vertical hyperbola, you will have y-intercepts and no x-intercepts. Why is that the case? We know how to find our x-intercepts and y-intercepts. If I want the y-intercept, I plug in a 0 for x and I solve for y. We know that this would just go away. And we know from our last lesson that the shortcut is I can just take the positive and negative square root of that denominator there. Plus or minus the square root of 9 is plus or minus 3. So my y-intercepts would occur at 0, 3 and 0, negative 3. And you might say, where did that come from? Again, if I plug in a 0 here, that term's gone. So you would have y squared over 9 is equal to 1. To get y by itself, I would multiply both sides of the equation by 9. Because in standard form, this guy always is equal to 1, whatever the denominator was here, it always ends up on that side of the equation. So I end up with y squared is equal to whatever that denominator was. Now, the end result to get y by itself is to take the square root, and over here I have to go plus or minus the square root of that guy. So the shortcut is always to look at the denominator and say plus or minus the square root of that. That will give me the y values for the y-intercepts. And again, you could do the same thing if you're working with x-intercepts. The concept is the same. So this gives me y is equal to plus or minus 3. Of course, we already know that. 0, 3 and 0, negative 3 are the y-intercepts. Now, you might say, why don't we have x-intercepts? Why does that occur? Well, because of this minus sign here, you're going to run into some problems. If I plugged in a 0 here, and this term was gone, you'd have negative x squared over 9 is equal to 1. Multiply both sides of the equation by 9, you'd have negative x squared is equal to 9. Now, let's say I divide both sides of the equation by negative 1 to get rid of that negative. So let's say we have x squared now is equal to negative 9. Is there a real solution that I can get there? No, there's not. Because if I take the square root of this side and I do plus or minus the square root of this side, the solution there is a complex solution. Although we can do it, when we think about just involving real numbers, we're not going to have a solution. So that's why we won't have any x-intercepts here. So let's erase this. And a similar thing will happen when you have a horizontal hyperbola. Now, we have our y-intercepts. The next thing I told you want to do is find this fundamental rectangle. So you'll see a formula for this in your book. The reason I don't teach this with the formula is because things are switching back and forth all the time. The A is different, the B is different, it's all over the place, and students have a hard time remembering. If you just remember that the first point you want to get is x comma y. Where does x come from? Where does y come from? For x, you take the principal square root of that number right there, whatever's under x squared. So the principal square root of 9 is 3. So it's 3. Now, for y, you take the principal square root of whatever is underneath the y squared variable. So in this case, that's 3 also. Then you're going to do a variation of this. So there's 4 points total to make this rectangle. So now I'll make this guy negative, and this guy will stay positive. Then I'll make this guy positive and this guy negative, and then I'll make them both negative. Getting the fundamental rectangle is very, very easy if you just follow that formula there. Again, just think about x and y in that format. Now, to get the asymptotes, they extend from the diagonals of this rectangle. So that's the easiest way to do it. If you want the formula for the asymptotes, all you'd have to do is say y is equal to plus or minus, you'll have a slope here, then times x. Now, where do I get this guy right here? Again, I want you to think about slope as rise over run. So there's going to be a vertical value that you move and a horizontal value that you move. Again, think about rise over run. So where do I get the rise from? Again, you take the principal square root of this guy right here, whatever is underneath y squared. So that's going to be 3. Where do I get the run? You go underneath the x squared variable, take the principal square root of that. That's going to be 3. In this particular case, we have the same denominator in each case. So it's really, really easy, right? We know that it would be 3 over 3 or just 1. So this is 1x, and you're going to have 2 scenarios. So one line would be y is equal to x. The other line would be y is equal to negative x. So let's take all of this information to the coordinate plane, and I'll show you how to sketch the graph. So let's start out with the y-intercepts. They occurred at 0, 3, and also 0, negative 3. So 0, 3 is right here. 0, negative 3 is right here. Then let's think about that rectangle. So we know the endpoints were at 3, 3. They were at 3, negative 3. Then we had negative 3, positive 3. And then we had negative 3, negative 3. So 3, 3 is right here. 3, negative 3 is right here. Negative 3, 3 is right here. And then negative 3, negative 3 is right here. So now we would connect those endpoints. Now once you have the rectangle drawn, you can extend from the diagonals your asymptotes. So you can either, again, extend these from the diagonals there, or you could just find the asymptotes on your own. Again, we found that it was y equals plus or minus 3 over 3, which is 1, times x. So this is y equals x, or y equals negative x. So if you did y equals x, that would give you this guy right here, this line right here. This is y equals x. So if I start at the origin, I go up 1, I go to the right 1, up 1 to the right 1, so on and so forth. Y equals negative x, that's going to be this guy right here. Okay, that's y equals negative x. Now, once you have all that drawn, you would think about the actual hyperbola. So I've had the computer draw this for us, just so it's accurate. But I'm going to trace over it. And again, when you draw this, each branch is going to go through an intercept and approach but not touch the asymptotes. So let's kind of start here, and we'll come down. And again, we'll go through this intercept here, and we will come back up. And again, we approach the asymptote, but we don't touch it. Let's do the same thing down here. Okay, so we'll take this through the intercept. Again, we approach the asymptote, but we do not touch it. Okay? And again, not perfect, but you're giving a general idea of what this guy looks like. Let's take a look at another one. So we have x squared over 4 minus y squared over 9, and this equals 1. So in this case, this guy right here is the dominant one. We know this is larger, because this minus the y squared over 9 is equal to positive 1. So again, this will tell me that if the x variable is involved in the larger term, or the term that's positive, however you want to think about that, it's a horizontal hyperbola. With a horizontal hyperbola, I will have x-intercepts and no y-intercepts. So how do I get my x-intercepts? The shortcut is to take that guy right there and take the principal and negative square root of that. So plus or minus the square root of 4 is plus or minus 2. So my x-intercepts occur at 2, 0 and negative 2, 0. All right, let's talk about the fundamental rectangle. So our rectangle. Again, how do we get these endpoints? I'm just going to say x, y. With the formulas you get in your textbooks, again, they go back and forth based on what's a, what's b. It's kind of all over the place, and it takes a lot to really memorize that stuff. If you just think about the fact that you're going to have an x value and a y value, it's very easy to get this. So for the rectangle, think about the first point that you would have. So it's x, y. Where does x come from? Take the square root of whatever's under x squared. The square root of 4 is 2. Where does y come from? Take the square root of whatever's under y squared. Square root of 9 is 3. So it's 2, 3, and then I get variations of that, so I end up with negative 2, 3. I end up with 2, negative 3, and I end up with -2 comma -3. Very easy once you think about it that way. You never have to remember any kind of crazy formulas. None of that. You get your rectangle right away. And some people don't even want the rectangle. They just want the asymptotes. You can do that too. The asymptotes are easy to find also. So y equals, you have your slope times x, right? Your slope. Again, what is slope? It's rise over run. Well, where do I get the rise from? Again, rise is vertical. We're thinking about the y variable. Again, take the principal square root of 9. That's 3. Then for the run, take the principal square root of 4. That's 2. So you would have y equals plus or minus 3/2 x. Plus or minus 3/2 x. Okay? That would be your two equations for the asymptotes. So let's take this information to the coordinate plane. Again, we saw that the x-intercepts are going to occur at 2, 0, and then -2, 0. So 2, 0 is here. -2, 0 is here. We found that the fundamental rectangle endpoints were what? We had 2, 3. We had -2, 3. We had 2, -3. And then we had -2, -3. So 2, 3 is right here. -2, 3 is right here. 2, -3 is right here. And -2, -3 is right here. So let's go ahead and make this rectangle. Okay, and again, once this is drawn, I can extend my asymptotes from the diagonals. So from here and here, I could make a line going through that. And then from here and here, I can make a line going through that. Or again, I could just find the equation. We found that it was y equals plus or minus 3/2 x. So y equals 3/2 x and y equals -3/2 x. So if I started at the origin, if I went up 3 units, so 1, 2, 3, and I went to the right 2, that would put me at that point there. If I went from the origin down 3 units, 1, 2, 3, and to the left 2, that puts me right there. So you can see that would be the line. So let's go ahead and sketch that guy. So let's graph the hyperbola now. So I would, again, approach the asymptotes, but I wouldn't touch them. And this guy is going to go through the intercept. And coming back around, I'm approaching the asymptote, but I'm not going to touch it. And again, pretty hard to do this freehand and be accurate, but that's why I pre-drew everything, just to make it a little bit better. Again, through the intercept, and then approaching the asymptote, but not touching. Let's take a look at one more. So we have x squared over 16 minus y squared over 16 equals 1. Again, this guy right here, you think about this as being the positive one, or the larger one, the more dominant one. In the end, x squared over 16 minus y squared over 16 is 1. So this guy has to be bigger. So this is going to be a horizontal hyperbola. So again, we'll have x-intercepts and no y-intercepts. So those would occur at 4, 0 and -4, 0. I got that by taking the principal and negative square root of 16, right? Plus or minus the square root of 16 is plus or minus 4. That's how I get the x values there and there. Getting the fundamental rectangle here is very easy because I have the same denominator in each case. So I know it would be 4, 4 to kind of get things started. And then I would do -4, 4. I would do 4, -4. And then I would do -4, -4. And again, this is all you really need. You can extend your asymptotes from the diagonals of the rectangle, or you can just figure out what the asymptotes are. In this case, again, you have 4 and 4, if I think about the square root of 16 and the square root of 16. So the asymptotes would just be y equals plus or minus 4 over 4 is 1, so y equals plus or minus x. All right, so let's take this information and let's graph this guy real quick. So again, the x-intercepts occurred at 4, 0, and you had -4, 0. So 4, 0 is here, -4, 0 is here. Then for the rectangle, again, we had the points 4, 4. You had -4, 4. you had 4 comma negative 4, and you had negative 4 comma negative 4. So for 4 comma 4, that's here. For negative 4 comma 4, that's here. For 4 comma negative 4, that's here. And then for negative 4 comma negative 4, that's here. Okay, so the rectangle is drawn. Again, if I want to, I can just extend the diagonals there and create my asymptotes. Or again, I know it's y equals x or y equals negative x. So starting here, I would go up 1 into the right one, up 1 into the right one, so on and so forth till I got to that point, or going down, it's the same thing. For the other guy, if it's y equals negative x, I would go down 1 into the right one, down 1 into the right one, so on and so forth. I'd have points down here. I could also make points going up here. Okay, so let's draw the asymptotes. So I have my asymptotes drawn. Again, it goes through the intercept. Again, it goes through the intercept. Okay. Again, not perfect, but you get the general idea of what the shape is, and that's all we're looking for when you're asked to do this freehand.